All right, this is the warm-up for your periodic trends. And so this page is going to resemble what your quiz is going to look like. The first thing you need to do is make sure you read your titles here: atomic radius, electronegativity, and ionization energy, and make sure you draw the appropriate arrows. We always draw in the direction that it is increasing. So we know atomic radius gets bigger to the left and going down. Electronegativity points to the right and up, and ionization energy points to the right and up. Remember, these titles change order, so you have to read them. Okay, let's talk about 5 definitions. Atomic radius is the size of an atom. Ionization energy is all about how much energy it takes to, and the key word for ionization is all about remove an electron. Electronegativity is how strongly an atom attracts an electron. A lot of people get these two mixed up, so make sure you know the definition of these two, okay? Effective nuclear charge is how strongly your protons are attracting your electrons. Remember, your protons are pulling on your electrons because they like each other. Okay, the pluses and the minuses love each other. Okay, it's all about that hug. How closely are they hugging each other? Electron distance is a distance from the nucleus to our outer electrons. So basically, how far are your protons from your electrons? Okay, so now let's talk about 3 examples that you could see. It's very similar to your quiz. All right, I'm going to go quicker than I did before because you should have a lot of practice already. So here we go. Which has the smallest atomic radius? Strontium, deuterium, silver, or iodine? Okay, so, all right, so let me mark them really quick. So we have strontium, deuterium, there's silver, and there's iodine. Okay, so smallest atomic radius. It gets bigger going to the left, so the smallest one is going to be iodine. Iodine has the smallest atomic radius of the elements in this period. Period tells us that we're talking about protons and Zeph. Iodine is on the far right-hand side, so it has the largest number of protons, which means it has the largest Zeph, resulting in a larger attraction because that hug is very, very strong between them. Okay, number 2, which has the largest ionization energy? Neon, argon, krypton, or xenon? Okay, let me mark them really quick. So they're all these noble gases over here. Ionization energy increases going up. So if it's looking for the largest one, then we are talking about neon. Neon has the largest ionization energy of the given elements in this group because they're all in the same column. Remember, group is all about energy levels and electron distance. So neon is on the second row, so has 2 energy levels. Xenon is on the 5th, so has 5 energy levels. So between the two, neon has the smallest number of energy levels. It only has 2. If it has smallest number of energy levels, right, it only has 2 rings, it means that the electron distance, is also very small. So it has the smallest electron distance. from the distance from the positive to the negative is very, very small. If that distance is very small, you're physically closer together. That means you have a larger attraction between them. All right, last one. Which has the smallest electronegativity? Beryllium, boron, oxygen, or fluorine? So let me mark those really quick. You have beryllium here, boron, oxygen, and fluorine. Electronegativity increases going to the right. It's looking for the smallest one. That means that beryllium is our answer. Beryllium has the smallest electronegativity of the given elements and they're all in the same row, which means they are in the same period. Period tells us we're talking about protons and Zeph. So you compare, beryllium has how many protons versus fluorine. Fluorine has how many protons? So beryllium has 4, fluorine has 9. So that means beryllium has the smallest number of protons, which means it has the smallest Zeph. Small protons means that pull, that hug, is very, very weak. If that hug is very, very weak, then the attraction must also be smaller than the rest of them. All right, so these are the answers to the warm-up.